Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 15.2, Problem 2. This is Section 15.2, Problem number 2. We want to solve the integral of 2x dx over x squared plus 1 in parentheses to the fifth power. Now, when you solve an integral, you can't really write it with a variable in the denominator. And if the x squared in the denominator were by itself, it didn't have the plus 1 with it, it didn't have the fifth power, I could easily just pull it up on top by making it an x to the negative 2 power. But because the plus 1 is with it and you have a fifth power, we need a different trick. And the only trick that I really see that would work for this is the substitution method. We have to write this in terms of a new variable so it can be written into a form with an integral that we can solve. So the first step in the substitution method is choose u. And your choices are stuff in parentheses, which we have, stuff in the denominator, which we have, power of e, which is not there, and stuff under the root, which is not there. So it's either going to be the entire denominator, including the fifth power, or just the value that's inside of the parentheses, the x squared plus 1. It'd be one of those two. In general, if stuff in the parentheses is one of your options, I will try that first. And what will happen is, if you've made the wrong choice, you'll hit a dead end where you can't solve the problem, and you go back and go with the other choice. So my choice is going to be u equals x squared plus 1. That's what's in the parentheses. So the second choice is find the derivative of u. du, derivative of u, equals, it's going to be 2x to the first. The x squared makes the 2x. The second power on the 2 comes down times the number in front of the x, which isn't written but understood to be 1. 2 times 1, there's the 2 in front. X to 1 less power. The second power drops to a first power. The plus 1 on the end has no variable, so its derivative is just 0. So it's 2x. And at the end, you write dx, which is really for a derivative with respect to x. So now the next step after that is rewrite the original integral in terms of the new variable. So the original integral had a 2x dx in the numerator. So 2x dx in terms of the new variable is equal to du. And in the denominator, my parentheses to the fifth power becomes u to the fifth power. So my new integral still has a variable in the denominator, but this is easy to deal with now, because before I do the integral, it's just going to get rewritten as u to the minus 5 du. Now I can solve that integral. So let's solve it. So what I'm going to have is 1 over, be careful because it's negative. Let's actually write out 1 over the old exponent plus 1, u to the old exponent plus 1, plus some constant. So it's going to be 1 over minus 4, a negative a fourth, u to the negative a fourth, u to the negative 4, rather, plus a constant. Now, that is the answer to the integral, but it has to be written in terms of the original variable x. So leave my negative 1/4 in front of the answer, and instead of u to the negative 4th, but the value of u in terms of x, which is x squared plus 1, in parentheses, to the negative 4 power, plus some constant. And that's the answer. If you prefer, because of the negative 4th power, you could put the x squared plus 1 in the denominator if you like. So you could have negative 1 over 4 times x squared plus 1 to the positive 4 plus some constant. These two values are the same, whether you put the parentheses in the numerator with a negative exponent or in the denominator with a positive exponent.